Madison, as a city, has really unique geography. It is one of a few cities in the United States to be situated on an isthmus, which, if you didn't know, is a small strip of land with sea on either side, or sea or some type of body of water. Because Madison is situated between two bodies of water, it is not extremely different than another landmass that we are also situated on. Now, of course, the magnitude of North America compared to the 94 square miles of Madison and the two bodies of water being the massive Atlantic and Pacific Oceans compared to the relatively small Lake Monona and Lake Mendota are quite big differences. But the general geography of Madison works well to convey tectonic plate boundaries and their effects on the topography of the land. Let's imagine that the west side of Madison, or the area situated on Lake Mendota, is a convergent subduction zone. In this case, the plate that the lake is situated on subducts under the plate that Madison is situated on and creates deep lake trenches closer to the coast and causes volcanic mountain ranges on top of Madison. We can imagine Madison's volcanic mountain ranges as the tall buildings that run from the highest topographic point on the isthmus, Bascom Hill, down State Street, and back up to the second highest topographic point on the isthmus, the Capitol. The topographic feature is very similar to the Cascade Mountain Range, which runs from the northern California to the southern British Columbia, with dispersed mountains in between. One other feature that correlates these two topographies well is generally across the west coast where this mountain range exists, the area east of the range are lower and generally sloped up, just as the buildings in Madison slowly slope down from the Capitol to Lake Mendota. Now, what did we learn today? First, convergent subduction zones are areas where two tectonic plates collide, and one zone, typically the ocean plate because it's more dense, subducts under the continental plate. Second, convergent subduction zones cause volcanic mountain ranges to form on the continental plate. And finally, third, partisan tectonic plate activity exists, and similar situations cause similar topography and geological effects as well. So we are able to model their activities on areas that may have similar topography but not the same situation. Similar geological processes create similar topography around the world.